Hi guys, I'm Prashant here from Basin Technologies. I teach Python over here and I teach over here the classroom programs. And right now I'm here to discuss a few programming paradigms available in Python. Python supports 4 programming paradigms. These are the functional codes, the procedural codes, the structural codes, and the object-oriented programming code. The other 3, functional, procedural, and structural, have got a small issue that yes, we can only define a few variables, and from all the variables we can define the various tasks. But with the object-oriented programming, we have got a few X factors. These X factors are like we can give a few variables to a few objects. Something like we can define that an employee has a name, employee has an age, employee has a salary, employee has various things. At the end of every month, the employee is getting the salary. From that, we can basically implement the get salary method, and all those things will be implemented over here. Now, while I start with this oops, I must say that yes, there is a particular way by which we can write our oops code, and basically oops is a theory which says that yes, before defining anything we need to have a particular schema of that thing. So let's suppose, for example, we have a car. Okay, so it's not like that the moment we have a car we start making a car. No, at first we try to define that yes, what should the car look like, what will the car constitute, what functionalities will the car try to achieve, and all those things. So that schema in the oops is known as a class. So we can say, we can define the class like, say I'm defining the class as employee, and this class employee has got a few attributes. Now we define the attributes here in a particular function, a particular method known as the init class, and inside the init class we try to write a self. I'll tell you what self in a few moments, but let's say the employee will be having a name, a age, a designation. Okay, and let's give this name, age, and designation to the employee. We can write that thing as self.name is equals to name, self.age is equals to age, and self.designation is equals to the designation. Now this is one sample class which I have built, where I have shown that the employee class will be having a name, age, and a designation. Now I am defining an employee, emp1. He is an employee and he is having a name. Say suppose the name is PK. He has an age of 28 and he has a designation of senior software developer. Okay, now once we have defined this name, we can see his name, age, and designation in the following pattern. We can write print emp1 dot name, emp1 dot age, and emp1 dot salary. I'm sorry for the salary part, the designation. Now if we try to execute this code, we'll be getting python oops.py. I don't know what's taking up, it's okay now. So see, we are getting the employee's name, employee's age, and the employee designation over here. This is something known as the data encapsulation, which is achieved through Python. This is how we try to achieve it. We are giving this name, we are giving this age, and we are giving this designation to the employee 1, who is known by the emp1. Now the moment we write this particular line, The moment we write this line, this method is being called. We don't have to call it. It's been called within. Okay, it's known as the initialization, and this init is known as the initializer. Okay, now the moment we write this line, this method, the init method, gets called, and the emp1 becomes self over here, and the pk becomes the name, the 28 becomes the age, and the designation becomes the senior software developer. This is how we basically try to give all this three information, the name, age, and designation, to this employee 1, and this name, age, and designation is being called, and this name is this name which is being given to the emp1.name. Since the self is the emp1, so emp1.name is the name. Now what are we trying to achieve from this? We are trying to achieve from this that if we give like emp2 is equals to, it's an employee with the name say LP, the age say suppose is 30, and the designation is SDE1. Okay, now if we just copy and paste this line, and if we try to write, and if we replace this thing as emp2, and again we are getting over here as emp2, and then we try to execute this code, we'll be getting the employee 2's details also. This is how we try to achieve the data encapsulation in the form of Python, in the Python language. Now this data, what do we mean by this data encapsulation? Data encapsulation we can say as that we are trying to hide this data from the outside world, and we are just saying that yes, each of the objects, these are the objects emp1 and emp2, these objects will be having the name, the age, and the designation. All of them will be having this. Now this is also a form of data hiding. What do we mean by data hiding? We are trying to hide this data from the outside world. We are trying to hide that this is the variable name. These three are the variables names which are basically associated with this class employee, and the moment we make an object of this particular class, these are the three details which we will be needing to initialize an employee. Now this employee may have a function also. Now we can say that def declare salary, and then we say that self and the salary. Okay, and then we say over here that self dot salary is equals to salary. Okay, what we are trying to achieve over here, just see, this is the initializer, and over here also we are trying to initialize the salary. Now what we are trying to achieve over here is that the moment we declare this employee 1, we are not giving him the salary. To give him the salary, we need to declare the salary something like this. Let me try to minimize this. Yes, now we say that emp1 dot declare salary, and then we say like, say suppose 20,000. Okay, now if you write, now this is how I give the salary to this particular employee. Now if I say that print emp1 dot salary, I'll be getting his salary details over here. See, 20,000 is coming. Now this is not a very good way to take the attributes out of this thing. Now what are we trying to achieve? What we are trying to do, just have a look. This is one form of data hiding where we use the public variable names. Now say suppose I don't want to use the public variable names. because say suppose in a normal organization we don't want to declare a person's age. If you are in an organization, you will be seeing that yes, there is a Skype for business over there, and in the Skype for business you normally don't see the person's age or salary. What you just see is his name and his designation, maximum a photograph. I'm just saying that yes, right now in this example I'm just taking the name and the designation only, and I'm trying to hide his age from over there. So I'm deleting the age, and over here since the employee must have an age, so I am declaring over here as none. Now I cannot directly access the, see there is a red line below it. Why is this coming? Because over here we just have got 2 attributes, and over here we are declaring 3 attributes because it is not taking the age parameter. So I am removing the age over here, but the employee must have an age. It's quite obvious. So while declaring the age, we'll be trying to declare this age as a public variable. As a private variable. Now how we define a private variable over here in OOPS? We give 2 underscores over here. Okay, so it's just a normal paradigm used to declare the private variables. So now this is a private variable, and now we want to declare this thing. We want to give it a value. We give the values to them with the use of setters and getters, normally known as the accessors and the mutators. The mutators are the setters and the accessors are the getters. Now I'm writing a method with the name of set.age, where I'm taking the object and I am taking the age parameter. Now I'm just writing over here that self.age is equals to age. Remember one thing, that despite this being a private variable, okay, we cannot this is a private variable, and despite this being a private variable, okay, this is accessible inside the class, but outside the class it's invisible. Just for an example, let me show you this thing. Obviously the age is not required over here. Now if we just try to write print emp1 dot age, okay, and if you're trying to print this thing, we'll be getting that it has got no attribute in the form of age, but age is there. This is a form of data hiding. Okay, this is a form of data hiding, and all these 3 attributes are encapsulated within this particular class. So this is how we basically set an age inside the class, and if we want to set the age, we'll be writing emp1 dot set age. Let's suppose I'm giving the value of 28. Okay, and now despite we are giving the value, we cannot take this value out. To take this value out, we'll be needing something known as the getter. So def get age, and then the self, and then we don't need anything except for self, and then we are just returning the self dot underscore underscore age. Now you can ask one thing, that yes, we are not having this age. Okay, this age is a private value. Okay, and this age is a private variable, and we are trying to send a value out. So this is how we basically send a value out, because this is just a variable. This stores nothing but a memory location which has a value. So we are sending the value out, and the variable is private. This thing you need to put this in your mind, that the variable is private and the value is not private. It's only the variable which is pointing to the value, and the variable is private, and we are storing the value inside the variable which is private. Now if we try to write this thing outside, that print emp1 dot get age, okay, we'll be needing I'm sorry for this. We are trying to declare this line. This line is not required. Typo. So just see, the age is now coming as 28 now. This is how we basically attain data hiding, and since we are declaring these things inside, this is known as the data encapsulation, which are two of the standing pillars of OOPS. Now I'll be showing you how can we use the public variables inside the class. The public variables may be used for, say suppose you want to know the number of employees in your organization. So that variable does not depend on any of the objects, but it belongs to the class. Now we can declare a public attribute like this. So let's say number of employees, and I'm initializing it to 0. Why I'm doing it to 0? Because 0 is a number, and the number of employees can only be in the form of numbers. And this is how we basically declare a we declare a class attribute. It does not belong to any of the objects, but it can be accessed by the object, which is not a good idea. Now say when I'm trying to when I'm initializing this particular object, okay, this is calling this particular method. So when this method is being called, what we are trying to do is say the employee dot number of employees is equals to 1. So each time this method is being called, the values, the name and the designation is being set to the self.name and self.designation, and this age is declared as none, and the employee count is increased by 1. So just for a demonstration, let's write as the employee dot number of employees, okay, and then we'll be printing this thing, and I'll be just copying and pasting this line, Control C, Control V, Control V, and say I am writing a string employee count, and Control C, Control V, and over here again Control V. Okay, so we are trying to print the employee count, and let's say this thing is employee count 1, employee count 2, and employee count 3. This is just to show you that yes, what's happening in each of the lines. Let's try to execute our code. Okay, employee dot number of employees is not coming. Why? Because there's a specific reason for that. There's a specific reason for that. The reason is this variable is a private one, okay, and we would be needing to write a particular function to access this particular variable. How can we do that? We can do it, let's say we are writing def return number of employees, and we don't need a self over here because this object basically belongs to the class and not the object. The self will only be used when we are dealing with the object attributes and not the class attributes. So over here we're just returning the employee dot number of employees, and then if we call this function, yes, I forgot something. We need to declare this thing as a static method because this is not belong to the class. So we need to declare this function as a static method. So what am I doing over here? I'm just changing this employee dot number of employees to the employee dot return number of employees. And now if we try to execute this code, we'll be getting that at first the employee count is 0, this one. Okay, then we are initializing a particular employee, and then the employee count becomes 1 from this line, and then we are again initializing an employee, and then in the next line the employee count is 2. Okay, so when no employee is being declared, we have got the employee count as 0. When one employee is declared, we have got the employee count as 1, and when the second employee is declared, we are getting the employee count as 2. This is how we basically deal with the class variables. Now the next thing, I must say that the object-oriented programming paradigm has got 4 pillars. One is encapsulation, other one is abstraction, other one is inheritance, and the last one is polymorphism. Now, what is inheritance? I must say the example of inheritance would be just like we humans are inheriting the animals, the employee is inheriting the human class, and the IT employee is inheriting the employee class. Okay, so we can declare this thing as, say, we don't need this, let's work with the IT employees. So I'm declaring a class IT employee, and the IT employee is inheriting the employee class. Okay, now I'll be showing you a few things over here. Now, what is something which is common in the IT employee class and the employee class? The only common thing is these things: the names, the age, the designation, the number of employees, the declared salary. These things will be common to both the employee class and the IT employee class, so we need not declare these things inside the IT employee class. Okay, but what the IT employee class may have different than the employee class is his skills. So let's say the IT employee class has, let me at first declare the initializer, and from the initializer I'm using the self keyword and say skills. I'm using the skills inside the IT employee class only because say the services employee has got a different set of skills. It will be different from the other ones also. So let's say the IT employee class has got, yes, obviously the IT employee class will also be having his name, age, and the salary. So we'll be declaring this thing over here. We can declare these things like the super dot init and his name and his designation. Now he need to accept the name and the designation also. So we are accepting the names and the designation, and we are sending him to the parent class. What is the super is doing? The super is basically calling the parent class over here, this one, and he is sending him the name and the designation, which will be initialized over here. Say suppose we are, along with the names and the designation, we are also sending the age. Okay, now for the age is not initialized inside the init class over here. So what we need to do, we need to call one more superclass, the same superclass. By super, what we mean that we are calling the parent class. So super dot set age, and then we are sending him the age. What is the age? Say we are accepting the age over here, and we are sending the age over here, this thing. Now, and we have one more attribute left, which is the skills, which is not common inside the parent class, name under designation. So we are writing this designation over here. So super, no, I'm sorry for this. So self dot skills is equals to skills. So let me show a demonstration on this. So let's say that, let me just comment out the rest of the lines just for convenience. So what am I doing is, let's say that emp1 is equals to an IT employee who has got a name. I'll name as, say, the PK. Okay, designation is, say, SD1. The age is, say, 28, and the skills, as I'm taking a list over here, let's say the skills are Python, Java, and C. Okay, now let's take this employee one detail. So print emp1 dot name, emp1 dot get age, emp1 dot, let's say one more thing over here. So the emp1 dot dsg, emp1 dot get age, and emp1 dot skills. Okay, let's try to execute this code, and we are having a problem. Now the problem over here is that super object but a string. I think I have an issue over here. Yep. Sorry, I forgot to write this opening and the closing brackets. It was a typo. So we have the employee's name, the employee's designation, the employee's age, and the employee's skills. Now the peculiar part over here is we are printing the emp1.getAge. The emp1.getAge is not present inside this IT employee. So how is this thing being called? Now this is a property of the inheritance, that if a particular method is not present inside the child class, it will be calling the base class for its execution. So it's getting the age from here, and this is how he is getting his age. This is the inheritance. Okay, the next thing is, let me write all the names over here. I'm sorry. So the data hiding, which is also known as the encapsulation, abstraction, inheritance, and the polymorphism. Now, I have discussed these three topics in a brief, obviously. Now I'll be discussing something known as the polymorphism. Now, what is polymorphism? Polymorphism is basically made up of two words. One is poly and the second one is morph. Poly plus morph. So poly means many and morph means forms. So if the same thing is present in multiple forms, we can say that yes, the class is doing polymorphism. Now let me just comment out these codes and let me show you a fresh example for the polymorphism. Now let's say that what we are doing over here is, let's say we are making a class of cat. Okay, and we are defining the initializer with the self and the self. I don't think anything more is required. And let's say let's take a name. Okay, let's give a cute name, and inside of this name what we are trying to do is that self.name is equals to name. Okay, and let's take a class dog, and inside this dog let's make a init class let's give him a name also, and self.name is equals to name. Let's write one function. Okay, def let's make it like both the cat and the dog has a tail, and both of them use their tails for different purposes. Cat uses a tail when it sees a prey. Dog uses his tail when he is happy. So let's write the function as wagging tail, and say write the self, just the self, and let's declare it as, let's print it like I am seeing a mouse. I am feeling hungry. Okay, and let's copy and paste this thing inside here, and def wagging tail, I feel happy. Okay, now let's try to declare an object of the cat and the mouse both. What I am seeing over here, it could be something, it's an inbuilt problem, let's avoid it. So let's say Pinky, let's say that cat1, his name is Pinky. Okay, and dog1 is equals to dog, let's give the name as bully. Okay, let's write a function which will be calling the wagging tail function of both of them. So def wag the tail, which is taking an object. Okay, and then what we are doing is we are making the object dot waging tail. Okay, we're just calling it. Now let's make a list of animals is equals to a cat 1 and a dog 1. Okay, and let's write this thing as for I in, or the better one would be for animal in list of animals, and let's call wag the tail with the animal. Okay, now let's see what's the output. Okay, that's why I was seeing that there was an error. Okay, sorry, I missed it. So now over here what's happening? Over here inside the list of animals, okay, we are having the list of animals over here, and inside it, for each of the animal in the list of animals, what's happening? We are calling this wag the tail animal function. Now wag the tail animal, at first he's taking the cat 1. Now here's the wag the tail function is being called, which is taking the object as the cat 1, and then he's taking the dog 1. So first thing what's happening is cat 1 dot waging tail. So when we declare the cat 1 dot waging tail, this line is being executed. Okay, and for the second one, when we are having the dog 1, so what's happening in over here? So we are having the dog 1 is being sent as an object to the wag the tail function, and then the dog 1 is calling the waging tail. So inside it, the waging tail of dog is being executed, and I feel happy is being written over here. This is one of the ways by which we attain polymorphism inside OOPS in Python. Now it can have several examples. One very lively example will be that the onClick function. Okay, so inside the onClick function, what we see that yes, it will be behaving differently for each of the functions. Like the onClick function, if it's being written on a checkbox, then it will be ticked. If it's being written on a link, a new link will be opening. If it's written on a checkbox, the checkbox will be ticked. This can be one example of polymorphism. In this case, what's happening that the same function is calling different objects functions, and for each of the object a different methodology, a different thing is being executed. This is how we basically try to achieve polymorphism in Python. Now with this we can try to achieve abstraction. Okay, let's try to write something like a class with the name of animal. Okay, and let's write def init and self and name. Okay, and just write self.name is equals to the name. Okay, we don't need this now, and we want the cat and the dog to inherit the class animal. So let's write it as animal over here also, and over here also. Since each of the animals will be having a name, and we have declared this over there itself, so I'm removing this name. So whenever we'll be declaring it, this method will be called. Okay, and let's say each animals required to eat. Okay, so how we attain abstraction over here is we try to declare something that we'll be writing a function over here, that's def eating food. Obviously each of the animals required to have food, otherwise they will die. So in this case we are just writing self and we'll be raising a not implemented error, and as a message we'll be writing that the animal is not getting food to eat. Now what am I trying to achieve over here? I'm trying to achieve that, yes, by the properties of inheritance, if I'm calling the eating food method, okay, this thing should be present over here in each of the classes which is inheriting the animal class. Now since this eating food is not implemented inside a dog, and if we try to call it, let's try that object.waging tail and object dot eating food, okay, what we'll be getting is a not implemented error. See, not implemented error, that the animal is not getting a food to eat, which is not good. Animal should get some food to eat. So what we need to do is that we are just enforcing each of the base classes, sorry, each of the child classes to implement the eating food method. Okay. Otherwise, if we don't implement and if we call the function, what will happen is that the error will be coming forward, and we don't want to see that. So it enforces that the eating food function should be implemented in each of the child classes. So we are writing the eating food, and just write a self over here, and we are writing as print the mouse is tasty, and over here we are trying to implement the same function in the dog class. So def eating food, and see the bone is big enough for my kid too. Okay, so let's try to execute this code, and we see that for each of the object, what's happening, the cat1 dot waging tail, cat1 dot eating food, and then dog1 dot waging tail and dog1 dot eating food is being implemented. Have a look on the output. This was a small introduction to object-oriented programming in Python. Obviously OOPS has got a lot of other things also, but this was just a short introduction. Let's see how it goes.